Hello students, today we will study elementary transformation or elementary operation of a matrix. So let's start. There are three elementary transformation. First one is that interchanging of any two rows or columns. Interchanging of any two rows or columns. We denoted by this property like this: Ri interchange Rj, or Ci interchange Cj. This is the sign of interchange, where I means 1, 2, 3 and so on, and J means also 1, 2 and 3 and so on. Suppose A is any matrix of order 3 by 3, like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a square matrix of order 3 by 3. Because here row and columns are same, so it is a square matrix, and the horizontal is the row 1, 2, 3, 3 rows, and the vertical is columns, that is 1, 2, 3. So it is the order is 3 by 3. Now we are applying this any property. If we applying, right, R1 is interchanged by R2, then we get this is the R1 and this is the R2, and this means R1 R2 interchange means R1 की पोजीशन पर R2 लाएंगे और R2 की पोजीशन पर R1 लाएंगे, like this 4, 5, 6. This is the second row, but it becomes the first row by using this operations, and the second row becomes the first row. The first row becomes the second row, like 1, 2, 3, 7, 8, 9. Let us say about this operations. C1, C2 is interchanged by C3. That is, this property we are applying for row or for columns. If we say about C2 interchange C3, then we get first column is that same, there is no change. But the second and third we interchange means that the third column becomes the second column. 3, 6, 9, and the second column becomes the third column, like 2, 5 and 9. So this is the first elementary operations. Now the second is that second operation is that multiplying all elements of any rows or columns by a non-zero scalar k, where k is non-zero. It means k is maybe any real number, non-zero real number. This denoted by Ri is replaced by Kri, or in the terms of columns, Ci is replaced by Kci, where I may be 1, 2, 3 and so on. That means R1 is replaced by 5R1. That is, you can multiply any scalars of any row or any columns. And suppose C2 is replaced by 7C2. That means the column C2 multiplied by the 7. That is, 7 is multiply all elements of C2. Suppose A is any matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. And if we say about R1 is replaced by 5R1. If we applying R1 is replaced by 5R1, then we get 5A1, 5A2, 5A3, B1, B2, B3, C1, C2, C3. And similarly, if we apply C2 is replaced by 7C2, then A1, B1, C1, this is the first column, and which remains the same. And the second column multiplied by 7, that is 7A2, 7B2, and 7C2, A3, B3, and C3. The third column also remains the same. Now the third property is that third elementary operation is that adding to the elements of any rows or columns, of a matrix the corresponding elements of any other row or column. Multiplied by a non-zero scalar k. This is a very important elementary transformation, most useful transformation. With the help of elementary transformation, we can find the inverse of a matrix. This elementary operation is mathematically we use like Ri is replaced by Ri plus K Rj. In terms of columns, like Ci is replaced by Ci plus K Cj, where I is 1, 2, 3 and so on, J is 1, 2 and 3 so on. For example, R1 is replaced by R1 plus 5R2, or C2 is replaced by C2 plus 3C3. How to apply these two operations on the matrix? Suppose A is any matrix like this 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now applying this property, R1 is replaced by R1 plus 5R2, means R1. First of all, we multiply by 5 on R2. This is R2 and this is R1. 1 plus 5 times of R2, 5 4 is 20. 2 plus 5 times of 5, that is 25. 3 plus 5 times of 6, that is 30. And the second and third row remains the same. That is 4, 5, 6, 7, 8 and 9. After simplification we get 21, 4, 7, 27, 5, 8 and 33, 6 and 9. Similarly, if we applying the column operations like this, C2 is replaced by C2 plus 3C3, then it becomes first column is the same, third column is the same, we change only the second column. First 4, 7 and here we multiply 3 on the third column and adding the second column, that is 2 plus 3 3 is 9 and 5 plus 6 3 is 18 and 8 plus 9 3 is 27 and the third column remains the same, that is 3, 6 and 9, and after simplification we get 1, 4, 7, 11, 23, 35, 3, 6, 9. So that's final. All there are the three properties: elementary transformation or elementary operations. And now, what the equivalent matrix? What is the equivalent matrix? If a matrix B is obtained from a matrix A by using one or more elementary transformation, then A and B both are the equivalent matrix and is denoted by this: A is equivalent to B. Equivalent matrix. If a matrix B is obtained from A by using one or more elementary transformation, then A and B both are the equivalent matrix. Said to be an equivalent matrix. For example, let A is a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Let a matrix B, which is obtained by using the elementary transformation, R1 is replaced by R1 plus 2 R2. That means V is equal to 1 plus 2 times of R2, that is 8, 2 plus 10 and 3 plus 12. And the second, third row are remains the same, that is 4, 5, 6, 7, 8 and 9. 9, 4, 7, 12, 5, 8, 15, 6 and 9. This is a matrix B, which is obtained from the matrix A by using the only one transformation. But here we can say one or more. You can use any more transformation. So this is the equivalent of A, and it denoted by A is equivalent to B. Here A and B both are the equivalent matrices. This is the definition of equivalent matrix. Now one more definition, elementary matrix. What is elementary matrix? A matrix is obtained from an identity matrix by using single elementary transformation. For example, first of all we write the definition. A matrix is obtained from an identity matrix by using single elementary transformation. For example, we have let I, where I is the identity matrix. And you know very well what is the identity matrix. Identity matrix is always the square matrix in which the diagonal elements 1 and the all elements except the diagonal elements are 0. That is, if we say about the identity matrix of order 3 by 3, that is 1 0 0 0 1 0 and 0 0 1. This is the identity matrix of order 3 by 3. It is also denoted by I3. And if we apply only one elementary transformation, like if we apply R1 is interchanged by R2, then we get the matrix which is denoted by the A is like 0 1 0 1 0 0 0 0 1. Here we interchange the first and second row. That is, the second row becomes the first row and first row becomes the second row. Then we get this matrix, and this is the elementary matrix because this matrix is obtained by using only one elementary operation, so it is a elementary matrix. Now that's final, that there are three elementary operations and the equivalent matrix and elementary matrix. So students, if you like my method of teaching or way of teaching, content, then please you subscribe my channel. My channel name is that Dr. J.P. VARSHNEY. You can search my channel in YouTube by Dr. J.P. VARSHNEY, J.P. VARSHNEY Math, and press the bell icon, and also any comments. And if you ask any more questions, then you please comment my channel. Thank you very much. Thank you once again. Thank you very much.